This is chapter 22, 23 exam, Anthony Navarro, question 3, part A. It asks, an imaginary cubical surface of side L has edges parallel to the x, y, and z axis. One corner at the point x equals 0, y equals 0, z equals 0, and the opposite corner at the point x equals L, y equals L, z equals L. The cube is in the region of uniform electric field. E equals E1I plus E2J, where E1 and E2 are positive constants. Calculate the electric fluid flux through the cube face in the plane of x equals 0 and the cube face in the plane x equals L. For each face, the normal points out of the cube. Okay, for this one, all we have to do is we have A with negative L to I. And we got this. It was E times A. And then we'll get E1 times I plus E2J negative L2I, which will equal negative E1L2, which will be for 0 for x equals 0, and then for x equals L, it will be A plus L2, and then E times A, which equals E1I plus E2J times L2 L squared I, which will equal E1L2, which will be there for L. Part B asks, calculate the electric flux through the cube face in the plane y equals 0 and the cube face in the plane y equals L. For each face with normal points out of the cube. So we want to find y equals 0 and y equals L. So for this one we do y equals 0 equals E1 L times L. Y equals E1 L squared. Y equals L equals L equals E2 L squared, which will then give us, since the opposite negative, since the first one y equals 0, x equals 0 is negative, it will be for the same thing for y, which will be negative E2 L squared, comma E2 L squared. Part C asks, calculate the electric flux through the cube face in the plane z equals 0 and the cube face in the plane z equals L for each of the face known points. So z equals 0 and z equals L. For this one, all we have to do is equals 0, z equals 0, and z equals L, which will basically give us 0, 0. Part D asks, calculate the electric flux through the entire cubical surface face the normal point of the cube. So we got z equals 0, we calculate that, we times the all of them together, it would just be 0. Part E, at a point charge Q is at the point x equals 0, y equals 0, z equals 0. An imaginary hemispherical surface made by starting with a spherical surface of radius r, centered on the point x equals 0, y equals 0, z equals 0, and cutting off the half in the region z less than 0. The normal to this surface points out the hemisphere away from the center. Calculate electric flux through the hemisphere of Q equals 6, N equals C, and R equals 0.100 meters. For this one, all we have to do is q over 2e0 equals 6 times 10 to the negative 9, all divided by 2 times 8.85 times 10 to the negative 12, which will give us 6 times 10 to the negative 9 divided by 2 times 8.85 to the 10 negative 12, which will give us approximate 339 Nicometer squared C. Part F asks for calculate the electric flux to the hemisphere of Q equals negative 8 Nico C and R equals 0.100. So for this, all we have to do is E equals negative 8 times 10 to the negative 9 divided by 2 times 8.85 times 10 to the negative 12, which will give us negative 8 times 10 to the negative 9 divided by 2 times 8.85 times 10 to the negative 12, which will give us negative 452 Nicometer squared over C. Part G, calculate the electric flux to the hemisphere Q equals negative 8 Nico C and R equals 2.200. So for this one, all we have to do is, which will be the same. Q equals negative 8 doesn't matter, because when you do the same formula, it'll be negative 8 times 10 to the negative 9 over 2 times 8.85 times 10 to the 12. So it's the same thing. It's the same number being used, so the answer will be the same. 452 Nicometer squared over C. Part H. As an imaginary cubic surface beside the length 5 cm has a point charge Q equals plus 6 Nico at the center. Calculate the electric flux to the entire closed surface. So for this one, all we have to do is the same formula. Q over E0 equals 6 times 10 to the negative 9 over 8.85 times 10 to the negative 12, which when we do that will give us 6 times 10 to the negative 9 divided by 8.85 times 10 to the negative 12, which will give us 678 Nicometer squared plus C. Part I, calculate the electric flux to one of the 6 faces of the cube. So for this one, we do one of the 6 faces of the cube, so this total, so we do total flux divided by 6, which will equal 678 divided by 6, which will give us 113 Nicometer squared plus C. Part J. Imaginary surface, spherical surface of radius 5 cm centered at the point x equals 0, y equals 0, z equals 0. Calculate the electric flux to the surface at a point charge Q1 equals plus 3 Nico C is located at x equals 1 and y equals 1 and z equals 0. So for this one, all we have to do is do 3 times 10 to the negative 9 divided by 8.85 times 10 to the negative 12. When we do that, 3 times 10 to the negative 9 divided by 8.85 times 10 to the negative 12, which will give us 339 Nicometer squared plus C. Part IJK, as calculate the net electric flux to the surface of the following charge are present. The charge in part J plus a point charge Q2 equals negative 8 Nico C at x equals 2 centimeters, y equals 0, and z equals negative 4 centimeters. So that's what we just do. 3 minus 8 times 10 to the negative 9, all divided by 8.85 times 10 to the negative 12, which will give us 3 minus 8 times 10 to the negative 9 divided by 8.85 times 10 to the negative 12, which will give us negative 565 Nicometers squared plus C. Plot KL. Calculate the net electric flux to the surface of the following charge are present. The charge in cup K plus a point charge Q3 equals plus 2 negative C, Kx equals 4, Y equals negative 2, Z equals 3. So for this one, so we got plus 2 at X equals 4, Y equals 2, Z equals 3. So for this one, it'll be the same as the previous one. Because we do 3 minus 8. Because we do 3 minus 8 again, times 10 to the negative 9 over 8.85 times 10 to the negative 12, which will give us the same answer of negative 565 Nicometers squared per C. And that's it.